What if I told you that you could understand, well, pretty much the entire universe with just a single sentence? Sounds impossible, right? Well, today we're gonna crack open Richard Feynman's legendary 6 easy pieces to hunt down that one single powerful idea. All right, let's just dive right in with a pretty big thought experiment. Imagine this. All of our scientific knowledge is about to be wiped out, gone. And you, yes you, can only save one sentence for the next generation. What do you pick? I mean, what single idea holds the most information, the most power, in the fewest possible words? So, to tackle a question that massive, we're gonna need a guide. And honestly, we couldn't ask for a better one. Our guide is the brilliant and frankly super charismatic physicist Richard Feynman. We're talking about one of the greatest scientific minds of the 20th century, but maybe even more importantly, one of its greatest teachers. I mean, look at this guy's resume. It's just incredible. Sure, he won a Nobel Prize for his work in quantum electrodynamics, that small stuff. But he also helped figure out what went wrong with the Space Shuttle Challenger and was dreaming up ideas for quantum computing way ahead of his time. He wasn't just some theorist locked away in an office. He was a master problem solver. And for our purposes today, he was an absolute master at making ridiculously complex things simple. And that brings us right back to our big, high-stakes question. This was actually a challenge that Feynman himself loved to pose. So imagine it again. Disaster strikes, all our books and computers are gone. What single statement, what one little nugget of knowledge would you give to the survivors to give them the biggest possible leg up in rebuilding, well, everything?
Well, here it is. This is Feynman's answer, the atomic hypothesis. Now, I know what you're thinking. It sounds kind of simple, right? All things are made of atoms. But Feynman argued that this one sentence, this one idea, contains more information and has more far-reaching consequences than any other idea in all of science. It's basically the master key that unlocks, well, pretty much everything else.
Okay, so how? How can one little idea explain so much? To see that, we have to do what Feynman did best. We have to change our perspective. Let's put on our imaginary Feynman glasses and take a look at the world from the atomic level up. And we're going to start with something we all see every single day, something that seems about as simple as it gets, just a single drop of water. From where we're standing, it's just water, smooth, clear, simple. But as we start to zoom in, a completely new reality starts to show up. Whoa. Suddenly, there's a whole hidden world in there, an entire ecosystem filled with tiny creatures, like paramecia, just swimming around, living their lives. So right away, that simple drop of water is way more complex than we thought. But believe it or not, we are nowhere near the bottom yet. So let's keep going. Let's push the magnification way, way further. We're not talking 100 times or 1,000. Let's magnify that same little drop of water 1 billion times. What do you think we'd see? We'd see this, a constant chaotic dance. This right here is the world the atomic hypothesis describes. That smooth, calm surface of the water, it's a total illusion. The reality is this swarm of individual particles, oxygen and hydrogen atoms, all of them just relentlessly jiggling, vibrating, and bouncing off each other. And this just perfectly explains the difference between solids and liquids. So, in a solid, like ice, those same atoms are all locked into a neat, rigid crystal. They're still vibrating, but they can't go anywhere. But in a liquid, they've got more energy, enough to break loose and just kind of tumble all over each other. It's the exact same atoms, just with a different amount of wiggling room. And this whole atomic dance thing, it even explains everyday feelings. You ever wonder why you feel cold when you get out of a swimming pool? It's because of this, right here. The water molecules on your skin are all jiggling around at different speeds. The fastest ones, the little superstars with the most energy, they actually escape and fly off into the air. That's evaporation. But when they leave, they take their energy with them. So the average energy of the water left on your skin drops. And that feeling, that's what we call cold. Okay, but the real power of this idea goes way beyond just explaining a drop of water or why we feel cold. It's much, much bigger than that. As we're about to see, this is basically the foundational language for all of natural science. No, really, think about it. What is physics? It's the study of how all these atoms move and bounce off each other. And chemistry? That's just the study of how atoms decide to link up, break apart, and swap partners to make new things. And biology? Oh, biology is just the mind-blowingly complex, beautiful result of all that chemistry happening on a massive scale. See? It all comes back down to the rules of these tiny jiggling particles. So, what's the big takeaway here? What are we supposed to do with all this? Because it's not just about knowing that atoms exist. It's about a completely different and really powerful way of thinking about everything. This right here is the heart of how Feynman thought. If you want to understand something that seems really, really complex, doesn't matter if it's a computer, the economy, or a living thing, don't get overwhelmed by the big picture. Go down to the smallest, most fundamental parts, understand their simple rules, and then build your understanding back up from there. Suddenly, the world starts to look a lot less mysterious and a lot more, well, understandable. And that brings us back to the beginning, but this time, the question is for you. Feynman picked the atomic hypothesis. That was his one sentence to save the world. But what about you? If you had to choose just one idea, and it could be from science, from art, from philosophy, from anywhere, what would you pass on? What single idea do you think holds the most power for our future?